My fabulous chemistry faithful, video number 4. We are halfway there. And you know what? This is just going to be another kind of definition type video. So we don't even have any tasks till next video. So let's get through right to it. Why some elements are radioactive? Well, it has to do with their ratio of protons to neutrons within the nucleus to determine if it is stable or not. It's 1 to 1, 2 to 1. There's a little graph over here about nuclear stability, and this is some of like the more college level um, thought processes about what's going on inside and where the stability is. Where that line is very linear, but there ends up being more neutrons as we get into the bigger molecules, right? And so everybody other heavier than 83 is going to definitely be unstable. 82 is lead. So anybody heavier than lead will naturally decay, period. Some isotopes of other elements would naturally decay. And and I get farther and farther and farther from 1 to 1, I tend to become more and more unstable. You can kind of think of the neutrons as the ability to glue all those positive guys together. But eventually, I just have so much mass in such a little space that it's just too much for the nucleus to handle, and we're going to give something off. So here are the 4 decay modes. You can see table O is here for you with different notation and symbols. Alpha is the little a. It's got these funny little tails on the top because it's supposed to be Greek, right? This is the heaviest form of dangerous radiation. Hence, it has the weakest penetrating power. So you can think of it this way. Penetrate means to go through. Alpha, decay, looking at the notation, is a helium nucleus. So a lot of times you'll see He with a 4 and a 2, or you'll see the alpha with the 4 and the 2. So it's 2 protons, 2 neutrons. So remember, atomic numbers on the bottom, that's where the 2 comes from. And then atomic mass is protons plus neutrons. So if there's 2 of each, the mass is 4. Um, Looking real quick down the chart, nobody else has more mass. Hence, it's the heaviest one. If it's heavy and big, it's not going to go through your hand. Okay, alpha is stuff that a piece of paper. I can just put up a piece of paper like this, and it stops it. I can stop it from hitting my head. You'll see some of the old school picking on crazy peoples when they put the tin foil on their heads to stop stuff coming through, right? So alpha is the little a. It is the nucleus of a helium atom, and you need to know it's 2 protons and 2 neutrons together, and that its penetrating power is very weak. Middle of the road is beta. Here I have charge but no mass. Okay, so aluminum foil, it would be enough to stop beta decay. And beta decay, if you look, has that weird B. Sometimes it could have the E with a -1 on the bottom. Generally, you see it as a B and a B with a -1, or a B with a negative symbol. So the symbol is just a little B with a negative, but notice it has that little tail on the B. Okay, so beta decay is next. Then it comes the boogeyman. So gamma is where all the bad stuff comes from, as far as causing cancer and the reason why you're not supposed to be in the sun too long. But you'll hear them talk about UV rays, but UV rays is not the biggest problem as far as your exposure to what's coming out of the sun. That would be gamma. Gamma radiation is the boogeyman. It has the highest penetrating power because it is just pure energy. So you need a good solid chunk of lead or many feet of reinforced concrete. We're talking 6 feet of concrete to be able to stop it. It has enough penetrating power to go through 6 feet of concrete. You see a concrete wall, it is not normally 6 feet wide. It's what, cinder blocks are this wide, so that's a foot. So imagine 6 cinder blocks sideways as the width of the wall, and then however long it is or high it is. So you need a lot of concrete to stop gamma. Gamma has crazy penetrating power. Gamma also has, I'm just looking to see, it has that weird symbol. It looks like to me, it's like a Y, but it's a loop Y. So it looks kind of like a Y to me. Okay, and then positrons are these rare types. They usually trigger fission reactions, but positron is going to look like a beta, except for it's positive. So it's actually a positively charged electron, and I believe it has something to do with neutrons and like a neutron taking the negative charge off of an electron or something. I forget exactly. It's been a year since I delved into it, but there's a process of making them. So if you want to do a little extra, how do positrons come to be? You can see um, the exact mechanism for it. It's kind of cute if I remember correctly. Right, and with that, see, that's video 4. Now we got to get into balancing equations and half-life, and we're done with the unit.